Good morning, everyone. I think I can start the class now. Before starting class, I want to remind you we have some online homework this week. 10.1, 10.2, 10.4, and interactive review we have 10R1, 10R2, and we have the handling homework 6 due tomorrow. All the things. And next Friday, this Friday, we will not have a class for you to do the exams. So you please spend your time doing the exam. This exam is just 2 hours. Okay. Regarding the exam 3, we only have 2 hours to do the exam. And for some special case, like students have a disability, so I can extend to 3 hours for the exams. Because in this exam we just have 23 questions. It's not too long. We have 23 questions. And the exam will be similar to the sample exam. I put this on Canvas, so please look at it and try to solve all the problems in the sample exam. Okay, and yeah, that's all the things about the exam 3. So do you have any questions? And now we continue to review. Okay, today I will review exam 3. We will have the chapter 7 is central limit theorem. And estimating population and proportion. The chapter 8. And final one, we hypothesis testing. It's just section 10.1. Fundamental about the hypothesis testing, like what is the hypothesis testing, some decisions, and what kind of error type 1, type 2, something like this, about hypothesis testing. So you have to know about the null hypothesis and alternative hypothesis. That is on chapter 10. Okay. And now I will move on to the first one, the central limit theorem in chapter 7. In this chapter, you need to remember how to use the central limit theorem to find the probabilities for the sample means and the sample proportions. So it depends on the question. It depends on the formula. The formula used here, it depends on the situation. For example, when the question has the mean, so we will use the formula in this table. Okay, and if they give you the proportion, so we will use the formula here. So look at the handout I give you in chapter 7. Okay, we have formula for sample proportion and sample mean here. A standard deviation, and especially you need to remember the standard score for each kind of sample mean or sample proportion. For the sample mean, we will use this formula. For the sample proportion, we will use this formula. Okay, so it depends on the case, you see. Okay. And now we move on to the first example. That is the question 1. So in the sample exam, question 1. In this case, they give you the mean, right? They give you, suppose the person in the last table has a mean weight of 11 and 28. They give you the mean. So the first thing we need to analyzing the questions. So they give you the mean here is 1, 11 and 28, right? And the second one, they give you the standard deviation. Standard deviation sigma here is 58. Okay. And also they give you the sample size. The sample size n here is 27. That's sample size. And the question here is to find the probability that the mean weight of the sample of horses would differ from the population mean by less than 10 pounds. What does it mean? Okay, I will draw the picture for this so you can easy to understand. We have the mean here is 1, 11, and 28. Okay. So they ask you, okay, look at the keyword. Okay, they want to find the probability differ from, okay, mu by less than 10, right? Okay, so that means we need to find the probabilities from the mu here. Mu minus 10 is, okay, it's 1, 1. That means we need to find the probability from that area from this number to this number, this value. So this is 1, 1, 38. Okay, then when they ask you to find the probabilities that the mean weight of the sample of horses would differ from the population mean by less than 10. So you minus mu to 10 and plus mu to 10. So we have two values here, and we need to find the area from this value to this value. Okay. And to find this, we need to change x value here to z value, right? We need to change the x value here to z value. Okay, we have two x value here, so we change it to z values corresponding to z value. Okay, and now because the question here is give you the mean, right? Give you the mean, so you look at the formula here. Look at the formula here. So we use this to calculate the standard score. They give you stable mean, so you use this to calculate the standard score here. Okay. And the z-score here is x1 minus mu over sigma square root of n. Okay, relate this. We have x1 here is 11, 18 minus 2, 11, 28. Sigma here is 58, and sample size is 37. And after that, you will use calculator to calculate the approximate value of this value. So you will get the value is approximately negative 1.05. Okay, and similarly, if you change to z here will be approximately 1.05. Okay, try to round your answer. To two decimal places. If you round into one decimal places, when you use the table, when you use standard normal distribution table, so we will get the incorrect answer, maybe. Okay, is it clear in this step? You just change to x value to z values. And now we need to find the area from negative 1.05 to the value 1.05. So we need to find this area, and I will calculate this area first. 1.05 minus to this area. Right. You can see the area here will be equal to this area minus to this area. So you can use your table to find this area. Okay, 1.05. So the area here is 0.85. Okay, so I write down here. And similarly, you will find the area for this is, okay, this value here like this. after that, when you find two z values, so you minus this and you will get the result here is 0. So that is the final answer. Okay, this is the final answer. Any question? Okay. So that is the solution for the first question. Okay, so now we go to the question 3. Okay. So look at the question. So you can see that they give you the mean or they give you the proportion in this question. Mean or proportion? Okay, check here. Okay, mean exactly. They give you the mean for this, right? They give you the mean. So we use the formula in table here. So we use the formula to calculate the standard score. Okay? When they give they give you the mean, so we use this formula to calculate the standard score. Okay. And look at this. So the first thing, when we do this kind of exercise, we need to analyze the questions. Question 3, so we analyze it. First thing, we need to they give you the mu, right? The mean here. So mean here is this number. And they give you the sigma, that is standard score, standard deviations. And they give you the sample size. Right? They give you the sample size. Okay. And now I will draw the picture for this. This is the mean, right? The mean here is this number. And they want to ask you to find the probability that the sample mean would differ from the true mean by more than. Okay, then the keyword here is differ from mu by more than. Okay, when they ask you like this, so here is the $36, right? So you use the mu minus to 36, so you will get this value, and you will plus mu to 36, you will get this value. And this means, what does it mean of this keyword? They want to find the probability that the sample mean would differ from mu by more than 36. That means they want to find out the areas. Find out the area of these regions. Okay, find area of these regions, and you know that two regions are equal, right? The area of two regions are equal, so you only need to find the area of each region, and after that you double of this area, so you can find the sum of the regions, right? Okay. And to find the area of this region, we need to change the x value to z value, right? We need to change the x value to z value. Okay. So z here, so equal to x minus mu sigma over square root of n. Okay. Use this formula because the question here gives you the mean, right? And when you relate all the value here. To this substitute it, so you will get the result. So approximately negative 0.69, and this guy is also similar like this. Okay. So now we will use the table of distribution to find the area of this region. Okay, use your table. So could you tell me? Okay, could you tell me the area of this region by using your table, using the standard normal distribution table? Okay, use your table. You don't have this. Okay, but you should have this in your exam. Otherwise, you cannot find the result. Okay. Find these the area. Okay, this is a negative 0.69. Can find the left area. So look at this. 69. So the value here is, okay, change it again.
0.245.
Yeah, exactly. Thank you. So the area here is 451, right? Okay. Because the area of this region and the area of this region is equal, so the sum of area is equal to 2 times to this value, right? And so the answer here is this value. Thank you. Thank you, Chivia. Is it clear, guys? Any questions so far about this problem? That's it about find the probability for the sample means. And now we move on to how to find the probability to proportion, sample proportion. Question 5. Okay. In this question, they give you the proportion. Okay. When they give you the proportion, we will use the formulas in this table. Okay. Especially, you need to remember how to use the standard score, how to calculate standard score. In this case, we have this formula here. Okay. Now, and we write down the solution of question 5. So we also do the same step like this. We need to analyze the questions. How to analyze this? So they give you the proportion, right? The proportion. The proportion here is 0.06, right? And they also give you the sample size here is 258. Okay, they give you 2 information about this. Okay. And we wrote down a picture for this. P here is 0.06. And they ask you to find the probability that the sample proportion will be less than 0.07. Okay. 0.07 here. So they ask you to find the area of this region. Right? Because they want to find the probability is that proportion, sample proportion is less than 0.07. That means they ask you to find the areas of these regions. Okay? How to do this? First thing, we need to change all the proportion here to z value. Okay, so how to do this? And you look at this table to find the standard score for sample proportion. Okay, the z here is equal to b hat minus b square root of, okay, p 1 minus p over n. Okay. The b hat here is exactly this number. So I will relate this is 0.07 minus 0.06 square root of 0.06 times 1 minus 0.06 over n here is 258. Okay. Just substitute every value here. So and you will get the result is approximately 0.68. Okay. And now, could you tell me what is the area of this one? Because you have the value here is 0.68, you can find the value here, the area of this one. How much? Could you tell me how much of this area? Could you tell me the area of this one? Okay, Lee, please.
0.7576.
Yeah, exactly. Thank you. So this is the area of this one is 0. Values. Okay, so that is the final result. Okay, final answer for this. Any question? It's for proportions. Okay, and that we finish chapter 7. Okay, so you can look at the question from 1 to 8 in the sample exam. From 1 to 8 is about chapter 7. Okay, chapter 7 from 1 to 8. So try to review it. Try to do the exams. Try to do the question in the sample exams. Okay. So now we move on to the chapter 8. That is estimating the population mean and proportion. So we estimating population mean and proportion. Okay, I will write the table for you to be easy to look at this. Okay, we have 3 columns. So this is the mean. So how to calculate it? So estimate the population mean. And this guy is population proportion. Okay, before we need to estimate this, we need to estimate the population mean and population proportion. We need to check the condition. The condition to estimate the population here is the simple random sample. When we want to get the sample to estimate the population mean, we need the technique here is simple random sample. This is the first condition. Okay, this is the same. This is the same. And the second condition here is sigma is known. That means the standard deviation is known. And the population proportion we have is the binomial distribution is satisfied. But we don't need to care about this, because we don't study about binomial distribution, so we don't care about this. We always assume this assumption also satisfied. And the sample size is approximately is greater than or equal 30, at least 30. And regarding the sample size here, it has to satisfy this condition. When you do the exam, maybe you don't need to check this condition, but when you do the handling homework, you need to check this condition. Okay. Okay, that is the condition. And what we have here, we have the first thing is the best boy estimate. The best boy estimate for the population mean is the sample mean. Okay, this is the sample mean. And the best boy estimate for population proportion is the sample proportion. However, when we use the best point estimate, that we will get the exact value for the population mean and population proportion. In some cases, when we do the best point estimate, we will get the incorrect result for the population mean and population proportion. So they will give you, they refer the interval estimate than the best point estimate in this chapter. And how to evaluate the interval estimate. That means we need to find the interval for estimating the population mean and population proportion. And to find this, we need to calculate the margin of error. The margin of error. For the population mean, the margin of error will be calculated by this formula. C is critical value times sigma over square root of n. And E here will be calculated by this formula. B hat 1 minus B hat. You can find these formula in my handout, but in this table I will summarize all the formula in this table. Okay. The chapter in the section 8.1 and 8.4. So I will summarize all the things here. When you find the margin of error, the critical value here to find by using the table 8.1. So you can find the critical value, right? And the final one will the interval estimate here. The interval estimate will be from x bar minus mu, x bar minus e less than mu less than x bar plus e. Similarly like this, b will greater than b hat minus e less than b hat plus e. And this that is the decimal estimate. And the minimum sample, one thing we need to remember is the minimum sample we need to use when we estimate this. Minimum sample size here. The n here will be calculated by this formula. Z alpha over 2 times sigma over e squared. And n here will be calculated by this formula. Z alpha over 2 over e squared. Okay, that's all the formula in chapter 8. Okay, so it depends on the question. If they ask you to estimate the population mean, so we use this table. If they ask you to find the population proportion, we will use this table. Okay. That's the all formulas for this. And now I will try to show you some problem, right? Okay, look at question 11. Okay. In this case, what kind of population parameter they ask you to estimate? Population means or the population proportion? Okay, Maria.
Mean.
Okay, mean. Exactly. Thank you. They ask you to find us just the population mean, estimate of population mean. And the first thing we need to analyzing the question, right? It's similar to these homework. Analyzing, we have sigma here is 2.4, and we have the H bar here is sample mean. The sample mean here, right? The mean electricity used per families were found to be 17.5 per day for a sample of this 796 families, right? So X bar here will be 17.5 and N here will be 796. Okay. And they also give you the confidence interval, confidence levels, right? Confidence level here is 90% and 0.9. Yeah, that's the confidence levels, right? Okay, we have all information about it. So you will look at here. So we can use it to find out the margin of error when you want to calculate the interval estimate. Okay, first thing we need to count the margin of error. The margin of error here will be Z alpha over 2 times sigma over square root of n. So could you tell me what is the critical value here? If we have the confidence level is 90%, so could you tell me what is the critical value in this case? Elite, please.
1.645.
Exactly 1.645. It's the critical value. Thank you. You use the table 8.1 to find the critical value for this, and substitute the standard deviation and sample size to this one, and we will get the result here is approximately 0.1. Okay. Because the question they ask you to round the answer to one decimal place, So I just round to one decimal place, right? If they ask you to find the interval and round your answer to two decimal place, so you have to write the two decimal place, right? And you have the margin of error we have here, so you can imply the upper estimate here is x bar minus e. X bar here is 17.5 minus 17.4, so we get the 0.1. Okay. So we get the 17.4. Okay, this is lower end point. This is lower estimate. Okay, lower end point. So I use the lower end point. And we have upper end point. The upper end point will be calculated by x bar plus margin of error. That should be 17.6. So we have the value of mu will be from 17.4 to 17.6. Okay, that's either the estimation for the population means. Any questions so far? Okay. Now, with that we finish the question 11. So now we look at the question 9. Question 9. In this question, they ask you to find the minimum number of males. Okay, that means they ask you to find the minimum sample size. Okay, I will write 9 here. Okay, question 9. So they ask you to find the minimum sample size when you estimate the mean population, right? So I write down the assumption here. We have mu here is the mean population mean here is 4.8, right? 4.8. And they give you the confidence levels. Here is the 95%. 0.95, and they give you the margin of error. The margin of error here is, look at the question 9, the margin of error here is maximum error of 0.09, so that means 0.09 is the margin of error. And they give you the standard deviation. The standard deviation here is 1.5, right? 1.5. And they ask you to find the minimum sample size to estimate the population mean. So we will use this formula, right? Use this formula. Okay, n here is equal to z alpha over 2 times sigma over e squared. Okay, the first thing we need to find which is the critical value in this case. Okay, could you tell me what is the critical values in this case? What is the critical value? They give you the level of confidence here is okay, not 95. Oh, 85%, right? 85%, not 95%. They give you the so z alpha over 2 here is okay, Maria.
1.44.
Yeah, exactly 1.44. Okay, thank you, Maria. And okay, substitute all the assumptions to these, so you will get this one is 1.44 times 1.5 times over 6e here squared, and you will get the result approximately okay, exactly this value. So you need to investigate at least 576 people to get these estimates. Okay. Any question? Okay, we go to the problem. Problem 13. This chapter 13. Look at the question 13. In this question, they don't give you any margin of error. They don't give you any point estimate, but they ask you to find the margin of error, right? They give you the interval, right? They give you the interval. Less than mu, less than this value, and they ask you to find the margin of error, right? So I will write down here. We have the point estimate here. And the margin of error will be the distance, will be the distance from the point estimate to the upper end point, right? This is E, right? Distance from the point estimate to upper end point. And E here is also equal to the point estimate to lower end point. In this case, they give you the lower end point here is this number, and the upper end point is this number. So how to find the point estimate in this case? And you can see here the point estimate is the midpoint in this line, right? So could you tell me how to calculate the point estimate if we have the lower end point and upper end point? Can you please?
Would you subtract the upper endpoint from the lower endpoint and then divide it by 2?
Okay. Okay. So it's not correct. For example, we have 1 here and 3 here. So what is the middle point?
It's in the middle, so it's 2.
2. How to calculate this? How to find 2? How you know this is 2?
Because it's in the middle.
If you get the 3 minus 1 over 2, so you get 1, right?
Also 3 plus. Also you add them.
Yeah, add the 1 plus 3 over 2. This one is 1 plus 3 over 2, right? If you have the lower end point 1, the upper end point 3, so the middle point is 2, right? Okay, because 1 plus 3 over 2 is 2. Okay, it's similarly to do this, right? So X bar here will be calculated by lower end point and plus the upper end point over 2. That we will find the point estimate. Okay, by the way, so thank you. You answer the lower end point plus upper end point over 2 here is equal to this value plus this value over 2. So you will get the result here is 15.81. Okay, you have the point estimate for this. And how to calculate the margin of error here? The margin of error here is the distance from the point estimate to the upper end point. That means that the margin of error will be the upper end point minus the point estimate. Right? Upper minus the point estimate. So the upper here is 17.51 minus to this value. So the margin of error will be 1.7. So the distance here is 1.7. Right? Is it clear, guys? That is the way to find the margin of error when you know the lower end point and you know the upper end point. Okay, when that we finish this chapter, so to practice, you will look at the question 9, question 10, question 11, question 12, question 13, question 14, and question 15. Okay. 16, 17, and 17. Okay. From 9 to 17. That's about the chapter 8. Okay, we move on to the final one. The final one is chapter 10, about the hypothesis testing. because we just learned about the hypothesis testing, so I just asked you about the fundamental of hypothesis testing, like determine which is the null hypothesis and which is the alternative hypothesis, which is the type error, something like this. I don't ask you to calculate or computations in this chapter. Okay, I will erase them. In chapter 10, in this chapter, I just asked you to the null hypothesis, alternative hypothesis, type error. Yeah, these kind of questions. Okay, we move on to the first question in this chapter. So you can look at the question 18. So in this question, they ask you to find the null hypothesis and the alternative hypothesis. The first thing we need to determine which kind of hypothesis they ask you, proportion or mean. Okay. In this question, they ask you. Okay, they give you a new Leicester publisher believe that about 30%. Okay, percentage here, that means that they ask you to say the null hypothesis and alternative hypothesis about population proportion, right? So the population proportion will be denoted by P, right? The value P. And is there sufficient evidence that at the level to substantiate, right? Substantiate. That means that it's the point. Okay. That means we need to support this kind of hypothesis, right? So the alternative hypothesis here is okay. Substance this plane. That means that the alternative hypothesis will be agree with this statement, right? Agree with this statement. That means the population proportion will be greater than 0.3. Okay, and of course the null hypothesis is opposite side of the alternative hypothesis, and it's always equal. Okay, it's always has an equal sign. That means P here is equal to 0.3. So that means that that is the null hypothesis and alternative hypothesis. When you write down to the answer, so you need to write the null hypothesis is P equal to 0.3, and this line you write P is greater than 0.3. That's about the hypothesis. Any questions so far about this question? Okay, question?
So the 0.05, would it really not
Yeah.
matter, so to say?
Doesn't matter. It's just they just this is the not the main information in this question. They are just asking like this. But you look at this one, substand or reject. Okay. Sometimes they want to write down here. If it's substand, we approve this assumption. If they reject, that means we did the opposite side of this one. So now we go to the 20 question 20. 20, okay. First thing, this is a multiple choice question. So first thing we need to determine which is the null hypothesis and alternative hypothesis here. Okay, a new letter publisher believe that over 47% of their readers on something like this, and the advertiser want to confirm this claim. Okay, confirm here is it's just to support the claim. Okay, it's the same as the support the claim. Okay, so the alternative hypothesis here is P here is greater than 0.47, right? And of course the null hypothesis is exactly this value, right? And okay, so look at the question, look at the conclusion. What is the conclusion regarding the public plane? Okay, the advertiser decide to reject, right? When they decide to reject, and look at the conclusion. There is sufficient evidence at the 001 level of significance that the percentage is over 47%, or there is not sufficient evidence. Okay, so could you tell me which answer? Okay, Liv, please.
A.
A.
There is sufficient evidence.
Yeah, exactly. Because they decide to reject, right? Decide to reject. That means they have enough evidence to accept the alternative hypothesis, right? So A is the answer. When they don't have enough evidence, not sufficient evidence to prove H alpha is incorrect, so they fail to reject the null hypothesis, right? Okay. One more question, and then we finish. One more question is 10 to 1. 10 to 1 is a type of error. Okay, I just write the table for you to understand here. So we have the table here, we have the decision here. The decision here, we have two decisions. We have to reject the null hypothesis, and we agree or not agree. We fail to reject null hypothesis. And when x0 is true and x0 is false. When x0 is true, when we reject x0, that means that is the error. That's the type 1 error. And we x0 is false and we reject it, that means we make the correct decision. And when x0 is true, when we fail to reject x0, that means we correct decision. And otherwise it's a type 2 error. Okay. That is table you need to remember. And the question 10 to 1 here, so you need to state the hypothesis and the null hypothesis here. The null hypothesis, the alternative hypothesis here is one parent claimed that the mean amount of television watched by children per night is less than 2.5. That is the alternative hypothesis. Mean here, okay, mean here, this is the mean. Mean is less than 2.5, and the null hypothesis is 2.5. Okay, and now we look at these. So look at the sentence. Assume that in reality, the mean amount of television watched by children per night is 2.3 hours. So if we have this statement, so could you tell me x0 is true or x0 is false?
It's false.
Yeah, it's exactly it's false because the reality here is 2.3. So that means the x0 is false. So x0 is false, so we choose this, right? But the decision here is fail to reject the null hypothesis, right? Fail to reject, and x0 is false. So we look at this, that is the type 2 error. Right? So we choose this answer. Type 2 error. Okay. Any questions so far? Okay. So spend your time doing your exam on Friday, and be careful when you do the exam, especially when it's have a question about the computation. So check the table carefully. Right? And now I will make the attendance for you. Okay, thank you for your attention. Samia here, Laurel here, right? Kylie here, Bobby, Christopher Dollar, Shaylee, Mackenzie, Bennett Rossinger, Abdul Hamid, Shama Chormeter, Kipling, Liv here, James Liu not here, Delaney Oaks, Ardelia. Number 2, Tyler here. Alia Smith, Yossi, Sullivan, Thomas, Priya, Cameron, Arthur, Tyler. Okay, thank you for your attention.